such as brown and black coal-fired plant, brown coal mining, open cycle gas turbine, hydro gas-fired boilers, wind and grid scale PV solar, along with the developments around the grid scale storage technologies. Shoei was heavily involved in the technical due diligence undertaken by AGL into the acquisition of the Macquarie generation and then led the AGL Macquarie operations integration team after the acquisition. Previously, Shoaib was the general manager of NRG Gladstone Power Station, it's Queensland's largest power station. He handled this post for 6 years. He has held number of roles in not only the power industry but also across a number of heavy industries and manufacturing in locations from Burnie, Tasmania, and Gladstone, Queensland, Australia. Those roles have included the fields of maintenance, production, and engineering technical services. Shoei has a particular passion and interest in milling, especially pulverizing, plant and process on which subjects he's published he published many articles. Shoei has been involved in the development of about 7 asset management program since the mid of 90s and the program development Gladstone Power Station GPS in the late 2000s, which won the national acclaim for its success in changing the culture and performance of the GPS business. With this introduction, I welcome Glenn Schumacher to this webinar. Thank you, sir.
Thank you very much. Professor Pai, would you like me to share my screen?
Yeah, please continue.
Yeah,
sir.
please go ahead.
Please,
Yeah.
Thank you. Just bear with me. I'm having trouble sharing it. Please tell me if that has come up.
Yeah, that has come up, but I think you've not shared the right screen. We can.
What about now?
No,
No,
not yet.
sorry. We'll try again.
Shall I share it from?
You might have to. It doesn't seem to be wanting to do that from this end. I'll try again. Let's see if that works. Now, has it come up?
Yeah, it is working now.
Yeah.
Okay, thank you very much. We'll go on to presentation mode. Well, good afternoon to my colleagues and some friends in India. I hope you're having a good afternoon. Very much thank Professor Pai for this opportunity to share some thoughts with you. This is a rather detailed presentation, so I'm not going to bore everybody by reading through this in detail. I want to cover off on the critical points. The full presentation will be available through the Asset Management Society of India website for people to read the details and any follow-up that they would like from that. So it will be available after this presentation. I just want to take this opportunity to talk about some highlights and then leave some time for a discussion at the end. So the title is Asset Management and Process Safety, a wind farm perspective. And it really is the elements of process safety that is at the core of this presentation. And we're dealing with a perspective of looking into India with regard wind. Now, I'm Australian based and my wind experience has been in Australia. So a lot of Australian examples are used in this presentation, and I'm sure you will forgive me for doing that because that is the basis I come from, and it would be inappropriate for me to make too many direct comparisons with India. You'll draw your own conclusions. But one thing that's included at the end of this webinar, the back part of this webinar, is a case study of an actual process safety failure in a wind turbine. So there's some real elements to this, and I've used examples on the way through to try and illustrate some of the points that need to be made. Firstly, some commentary about India. The growth of wind in India has been quite substantial, and we'll see some data on that. And has continued to expect to grow at a rate of about 42% over the next few years to reach a level of about $93 billion by 2030. So we're talking about significant investments, a significant part of the Indian energy landscape, and one that has been growing, from my understanding, in importance for India as it looks to broaden its sources of power, particularly given issues such as climate change and so on. So we're talking about a significant investment, and we're talking about a significant contributor to the well-being of the Indian economy. And as I said, it's growing. My estimate, looking at the data that's available, is we're currently talking about a fleet of in excess of 24,000 wind turbines across India. And as you folks know, mainly concentrated on the western side of the Indian subcontinent. So very predominantly on that western side due to the prevailing winds. But the growth going forward, again, 178 projects currently listed in India, 178 wind projects, is a significant, as I said, growth area, a significant area of investment, and one that I would suggest, a deep thought has to go into making sure it's done well if India is to optimize this investment going forward. And we're talking about significant amounts of energy. 48,000 installed megawatts is a large amount of generating capacity. However, the problem with wind around the world is you can only generate from it when the wind blows. So there's always a lot of capacity needed to get the generation required. So whilst the installed capacity, and this is true in every part of the world, is quite high. So in this case, nearly 10.5% of India's installed generating capacity is from wind turbines. That's only producing around 5%, and that's about what we see worldwide. So this is one of the challenges of solar and wind is the capacity factor, and the fact that we need a lot of installed capacity to get the generation we needed. However, 5% in India, roughly on my calculation, that represents 97,000 terawatt hours of electricity. So we're talking about very big numbers. Every time we start to look at these issues in the Indian context, the numbers are very big very quickly. So again, I make the point that the wind industry is a significant area for us to be thinking about asset management and all of the things that go around it, including process safety. And the growth rate, you can see between these two graphs that the growth rate has been very substantial from the early 2000s. We saw quite a rapid growth up until about 2014. A little bit of steadying off has occurred recently, and probably getting to whilst we'll continue to see growth, it won't probably be as substantial as the earlier period. However, the importance of this is that now those earlier wind turbines are approaching the end of their life. And when we start talking about asset management, that becomes a significant thing. But particularly when we're talking about process safety, aging plant, no matter what type of plant it is, poses some significant challenges. And so it is not unreasonable to start to see Indian wind plants come to the end of their life. And of course, this will be a progressive realization as we go forward. Now, we know there around the world, we do a lot of work on extending the life of generating plant, whether that be coal plant or what hydro plant or whatever. And we're seeing some efforts in the wind space, particularly in Europe, where there's an older fleet. And there's a lot of work going into how to extend the life of that. However, that aside, the fact is a lot of the older turbines are coming to the end of their lives, of their design lives and operating lives. And that is going to start to become a more significant factor. And we see some of this manifesting, and this is an Indian example from Gujarat, where due to climatic conditions, we see failures in wind turbines, and we're going to be talking about process safety. So we're interested in failures. In this case, it was reportedly due to a tropical cyclone and very, very high winds and an early design of wind turbine, and a significant number of wind turbines were lost in this 1998 catastrophic cyclone that hit India. So we're already seeing failures, some of them due to nature, but some of them due to plant. So asset management and process safety are already things that I would suggest we need to be giving some consideration to. So what is process safety? Is this just the latest management thing? What's it really all about? Process safety is really dealing with plant failures that can affect the plant and affect people, but are very unlikely in that they don't occur very often. But the consequences, such as the collapse of a wind turbine, are significant. They're severe. So the way we try to communicate in the corporate world, at least in Australia, about the difference between what we've traditionally thought of as safety, so that's personnel or occupational safety, and process safety, is given by this little cartoon. Personal safety, safety of you and I, whether that be in a plant or anywhere, think of that if we trip and we fall down some stairs. But the process safety failure would be if the stairs collapsed underneath us. So that's just a good way of thinking about this. Process safety has a long tradition going back to some notorious failures. Piper Alpha in the North Sea, which most people will be very familiar with, but a number of failures in the petrochemical industry, failures in the rail system in Britain, and there's a whole heap of literature and studies on these kinds of severe consequence but low likelihood issues. One of them in recent times has been the failure in the Gulf of Mexico of the BP platform, and one that sadly appears in all the literature around process safety, of course, is very close to the heart of people on this call, and that is Bhopal. And that really brings home the importance of what we're talking about here. So process safety and occupational or personal safety cross over one another. They interact. but they are different and we need to think of them differently. Process safety is very much embedded with asset management, and it's very much an engineering undertaking, whereas occupational safety has tended to be a field all of its own. Process safety needs to be considered very differently, and it is married to good asset management. So the way to think about this, we always think about risk. We come back to risk, and asset management involves risk. And process safety is all about understanding those risks. And again, I'm a visual thinker, so I tend to like these things that allow me to picture what we're talking about. As I said, process safety is about very low probability, but extreme consequences. So this is the cartoon on the upper left-hand corner of the slide. Low probability, high risk. If it goes wrong, it's going to be significant. Doesn't go wrong very often, but when it does, it really is very, very serious. So we need to prevent it going wrong is the bottom line. And for those familiar with this field, the classic is what's referred to as James Reason's Swiss cheese model. James Reason from Cambridge University did a lot of work on, University of Manchester, did a lot of work on process safety in the early days. This is 1990. Following those instances I talked about, Piper Alpha, number of rail failures in the UK, a number of petrochemical failures, and so on. And he came up with this image. So if we all think of Swiss cheese with all its holes in it, each slice of cheese is a barrier. It might be how the plant is built, it might be the training, it might be the maintenance, it might be all of those kinds of things. And each one of those is a barrier for something initiating, a failure initiating in the plant, and that failure going all the way through to harm. And it's the harm, whether it be of the plant or of our people or our community, or our environment, that we want to prevent. And James' Reason's thinking was there are holes in all of the barriers that we have. If those holes happen to line up so that the barriers are ineffective and the holes line up, all barriers are ineffective. An incident, a failure at one end results in harm at the other. And that's where the Swiss cheese model process safety comes from. As I said, process safety and asset management go hand in hand. How is that? Asset management, we really need to think about as a cycle. We go through the life from creating an asset, utilizing it, maintaining it, changing it, renewing it, and then eventually disposing of it. And within that, perhaps linear view of the life of an asset, we have a cycle. We have that cycle of maintaining, of operating, of renewing, and so on, going round and round and round. So we have a cycle within this system. And core to asset management is asset integrity. So by asset integrity, I mean, is the plant fit for purpose? Is it kept in purpose? Is it operated to purpose? So we're interested in the design and build of any particular item, whether that be a wind turbine, a railway bridge, a pipeline, whatever the asset is. Have we designed it and built it appropriately? Do we maintain it appropriately across its life as things change? And that includes renewing as things wear out, as things change around that asset. And do we operate the asset appropriately? So all of those three things need to come together to ensure that we have integrity in our asset. And this is where the interface between asset management and process safety comes to the fore. Process safety is about that, ensuring that integrity in the plant, that the plant does what we ask it to do, that the wind turbine tower doesn't collapse, that the blades don't come off, the bridge doesn't collapse, the boiler doesn't explode. That's the things that a process safety is interested in, and that is the crossover with asset integrity, which is at the core of good asset management. So this is specifically about wind farms. So we come back to, well, what can go wrong? One of the challenges we've got in asset management is, in many ways, it's grown out of large single point assets, whether that be an airport, a power station, a mine, a petroleum plant. They're large single point assets, have lots of elements in them, but they're concentrated. Then asset management evolved with things like railways and pipelines, power distribution, communication networks, to what I describe as linear assets. So they're no longer point sources, they're linear. And so that requires a different set of thinking about how we manage those assets as opposed to those single point assets. When we come to talk about wind farms, we have a different array of assets. And this is one of the reasons why I don't think we have the maturity in the wind space that we have developed in the single point and in the linear assets. Because we're now dealing with smaller assets, lots more of them, and not necessarily connected linearly like a rail line. Am I still connected, Professor Pai?
Yes, you are.
Sorry, there's just a warning came up. The internet was weak. Sorry. So I don't think at the heart of it, we've really thought about the wind assets like we have traditionally other assets in terms of asset management. So we need to change our thinking and adapt the models. But that's also meant that we haven't really thought about wind turbines, which is really the core of what we're talking about today, in terms of process safety. This is due not only to the fact we're dealing with a different class of asset, these distributed assets, but also that traditionally process safety has been associated with containing leakages, whether that be steam or gas or energy sources that could leak. That's where we came from in terms of the petrochemical industry and so on. That was the start of it. And a lot of thinking about process safety has been about containment. Well, we don't really have those kinds of things in the process safety space. In the wind energy space, we have a different set of failures. So our thinking about process safety needs to change as well. But we are dealing with failures that do fall into the process safety space. Fire. And
We lost your screen share.
Okay, Gopi, let me try that again. Yeah, so something's gone wrong with my network. Is it back now, Gopi?
Yes. Yes.
Okay, sorry. So we're talking about things like fire. And here we start to use some Australian examples. So forgive me because this is material I've got personal experience with. So wind fires, and we'll look at that in a bit more detail shortly. We have seen collapses in wind turbines. We have seen blades falling off wind turbines. So these are process safety failures. They are in many times asset management failures. So we need to start thinking differently, but clearly there is a need for thinking about process safety. And blade failures have become one that have become very topical in a lot of the literature. And this is an Indian example, the one photograph here in Maharashtra, sorry, pronunciation's not well, last year. So here is a wind turbine collapsing in India. So whilst a lot of this is based on Australian experience, there are well documented examples already in India. And it's not only Australia and India, we're seeing around the world collapses of wind turbines. It's a growing concern, and we're seeing these in Europe where the industry is very mature. We're seeing it in the US, we're seeing it in a number of places, and definitely we're seeing them in China, even though that's very hard to find data on. Sources that I've spoken to are saying this has become a big problem. One of the challenges is we're seeing wind turbines growing in size, and growing in size means they're getting taller. We're dealing with much more challenging structures. And when we look in the insurance world, because they're the people who are collecting the data, this is an interesting comment. We're seeing these failures happening in shorter and shorter frames for new turbines because the turbines are getting bigger. And that's bringing a whole heap of new challenges around structural integrity, blades, and so on. So the insurance industry is starting to see an increasing early life failure rate in terms of collapse and blade failures. And when we start talking about blade failures, here's an example. We've got blades 80 meters long, weighing 26, nearly 27 tons. That's a significant item if it fails, and clearly in a 3-blade wind turbine, the failure of one blade can often mean the failure of the complete turbine. So they're not inconsequential failures. They're significant failures of their own right. And this has been growing. Of the failure data around the world, and there are various sources that you can correlate here, blade failures seem to be the biggest form of failure, followed by fire and structural failure. So all three of those, and I've mentioned them, are significant process safety and asset management issues. If I come specifically to India, and we start talking about this, you can see the example on the right-hand side of an Indian blade failure where the blade is, the leading edge is failing on that blade rather significantly. It's delaminating, everything's going wrong. This is very interesting data from 2021, looking at when those failures are occurring and the nature of those failures. And it's very interesting in this Indian data to see those failures concentrating in the early life. And when we look deeper into how the wind turbines are being managed, one of the interesting things in India, much of it is done in-house by the wind farm owners. So 34% of all of the maintenance and care is done in-house, not using the OEMs, which has been a tradition in Australia. We relied on the OEMs to do a lot of this work, but in India it's being done in-house. But the other thing out of this data, and it is 2021 data, was that nearly 20% of that maintenance was based on emergency or breakdown maintenance, as we call it. And when we look at the basis of maintenance, there is some room for concern and improvement if we rely on 20% of emergency maintenance. So that's interesting Indian data, which to me says this is an area worth exploring. So what might go wrong? We've talked about fire, and the internet is full of images of wind turbines burning. Mainly they act like a Roman candle once there is a fire, because they get a natural draft through the structure, and the upper structure is plastic usually with some metal structure in it, but the nacelle is basically a plastic object. You've got electrical equipment, you've got rotating machinery, and when you have a fire, once there's a fire established, there's no real coming back from that situation. Structural collapse due to a number of causes. As you saw, that is about 9.5% of the failures that have been found around the world, and clearly that's a catastrophic situation. But even blade failures, and this image is very clear, you might get a blade come off, or you just get enormous instability, and you end up, you can do enormous damage. And in many cases, there are plenty of cases in Australia where a single blade has come off and the turbine has survived and been recovered. But there are many cases around the world where the turbine has not operated again. But my personal experience has also been things that don't rate highly but cause enormous problems. So this is an example of a generator failure. Now, in my career, at one stage we had 99 wind turbines that were identical, and they all started to develop generator end winding failures. So when you've got 99 turbines all the same and they're all failing, and that generator is up there in the air, this becomes a very significant issue, and you do not want to be in that nacelle when this kind of catastrophic failure occurs. And we had these kinds of failures, and they're very hard to deal with. So we've tried to map over the years where the failures occur and what might be the underlying causes and what we should be looking at. And this, as I said, it'll be available on the website, so there's no need to get into the detail. But this is an attempt to try and give people a starting place to think about those failures in wind turbines. I've talked about fires. This has become an increasing area of concern. Again, the insurance world, but also a number of other sometimes questionable forums. But when you correlate the data, we have seen a lot of fires in wind turbines, and the example at the end of this, the case study at the end of this, is one of those. And as I said, the web is full of some fantastic, if very frightening, photographs of what this can look like. And the cost can be very high. This is 2023, where the general view of a cost of a 2 megawatt turbine fire is in the order of 4 to 5 million euros. I'm sorry, I didn't convert that into Indian currency, but a significant loss. And so we want to avoid this. This is a very famous Indian wind turbine fire, primarily because of the smoke effect you can see on the right, which the turbine generated this vortex. But this is in Tamil Nadu in 2016. But this photograph, or these photographs, get reproduced quite a bit. So yeah, it's an issue playing out in India as well. Blade failures, the biggest single cause. In this case, you can see a single blade has come away, but you can see it's done quite a bit of other damage to the turbine. And if they're operating, the imbalance can, in fact, destroy the other blades and, in fact, destroy the mount as well. So that becomes an issue. And blade failure is an area of a lot of investigation. And coming back to that earlier data from India, and we start to see things like manufacturing defects in the early days, very common in blade failures. So they can fail quite early, and they do pose a massive, when you see them 26 to 30 odd tons now, a massive asset management issue, and as I said, potentially can destroy the whole tower. Structural failures have not been so common, but we are starting to see with those bigger wind turbines, as the data previously pointed out, with the bigger wind turbines, we're seeing an increasing failure rate, and that's a growing area of some concern. And there are all kinds of other issues that are going on in terms of failures and trying to understand what the root causes of those failures are. So again, the case for both good asset management and process safety is very strong. And this is just repeating the same kind of data, but the important thing out of this data from up to 2023, the one that I find worth pointing out is the fatal accident rate at 4%. So people think, oh, well, if the wind turbine collapses, it's in the middle of nowhere. Probably not going to hurt anybody unless there's a technician in the nacelle or somewhere. But the data is saying that there have been a significant number of people killed in these failures. So worth keeping that in mind. So I mentioned a case study. This is an actual wind turbine here in Australia, a 2 megawatt machine, 60 metre tower. It was one of 33 turbines in this wind farm, 80 metre rotor diameter, and getting on into midlife, this particular wind farm. So not new, but this wind farm suffered an interesting failure. It's a fire at first look. Here's the details of the particular model of wind turbine that we're talking about. And the interesting element is number 11 out there on the right-hand side, the high voltage transformer. Sorry, left-hand side. So the high voltage transformer is an interesting item in this failure when you start to work through to find the root cause. And I've pointed it out there. This is the failed nacelle when it's been brought back down to the ground because it was written off. The turbine was 100% failure and had to be decommissioned and demolished. And you can see that transformer in the back of what had been the nacelle. And you can see the nacelle, the plastic nacelle, is totally gone, consumed in the fire, and you're left with the structure. And I won't go into the details of the actual transformer, but we're really what happened here is that due to some corrosion of some fasteners, some studs that we'll see in a minute, this transformer over time was able to move. And wind turbines can be a pretty bumpy place. And because of corrosion in the fasteners, in the studs, this transformer was able to move around, and windings came in contact with the iron core. So we need to understand the root causes of what's happened here. Yes, we've had a fire, but where did the fire come from and what caused that fire? And so fire, trace back to the transformer, trace back to arcing of the low voltage windings. The examination post the failure said that we had this arcing that is very highly the cause of the fire. What allowed this to happen? And when you look further, and this is the importance of things such as root cause analysis, these are the securing mounts. So there's a locking block with some studs. I think they're studs which secured the structure that the transformer sat on. When they were examined, it was very clear that there was corrosion at the end of the bolts. Sorry, they are bolts. There's a nut. And you can see the corrosion there. You don't need a microscope. You don't need to be a forensic engineer or a metallurgist. There was clear corrosion over a long period of time from the thread under the nut. Now, this wind farm is on the coast, so it does see salt air blowing on with the wind. So it clearly, salt air is a significant issue, but we are also seeing corrosion in some surprising areas, such as in some dry climates. And Australia's got more than its share of dry climates. So thinking you're away from the coast, you're in a dry climate, I don't need to think about corrosion, please check again, because there's some very interesting areas. But this one, it was primarily due probably to that long period of salt spray, and we've had crevice corrosion occurring. So finding the root cause is really important, and you can see that this thing is a bit of a mess. And again, this is just information about corrosion and various other degradations which can cause problems in this kind of area. And, you know, condensation is one. You think, well, I'm in a dry area. How am I getting condensation? We're seeing in some of these dry, hot areas at night time, condensation is occurring in the nacelles. So we've had a hot day, hot air is present in the nacelle. It's very high up. The night comes, it gets cold, very cold in some areas at night, and we get condensation in the nacelle. Once we've got water, we've got ferrous components, we've got other things, we get galvanic corrosion. So please don't just think because you're not near the coast that this isn't an issue. And in this case, you know, there's some whole heap of areas where corrosion isn't always so obvious. So you've kind of got to think about it and go looking for it. You know, we're seeing it in under nuts and in crevices and all kinds of places. So need to be aware of it, need to go looking for it. And this is why good root cause analysis, good asset management becomes so important. And with that, thank you.
Yeah, thank you, Glenn. I now request Dr. Binu to propose the formal vote of thanks.
Yes, sir. So am I audible?
Yes.
Yeah. Good afternoon, everyone. It is my privilege to deliver the vote of thanks for this insightful session on asset management and process safety, a wind farm perspective. Let me begin by expressing a gratitude to Mr. Glenn Schumacher for his detailed and thought-provoking insights into wind turbine failures, asset lifecycle management, and process safety. His discussion on the failure mechanisms, the emergency-based maintenance, and proactive safety measures has been highly relevant to the challenges faced by this industry. And some of the key takeaways from today's session is about wind turbine failures and maintenance strategies. With, as Mr. Schumacher said, with 19% of maintenance being emergency based and structural cracks, fire, and operational errors being the leading reasons for failure, a like more comprehensive approach to asset management becomes very important. And the second key takeaway is the process safety and reliability aspects. So a special thanks to Asset Management Society India for organizing this valuable session and for leading the discussions on engineering best practices in asset safety and management. I extend my gratitude to Dr. Raghuveer Pai and Professor Ashutosh Sarkar and all the Asset Management Society India members for their efforts in bringing together industry and academia. To all the attendees, thank you for your active participation, and we look forward to many more enriching sessions in the future. Thank you, and I wish you all a great day ahead.
Yeah, thank you, Dr. Binu. I see that Gopi has a question.
Yeah, I think we are really fortunate that Dr. Glenn Shoemaker has shared his thoughts, and many of these engineering and the asset management principles and fundamentals are known, but sometimes the cultural and leadership plays in these organizations because if things are going right, people try to do this cost cutting and they try to look into the short term, how to change that culture, because that is the one thing, because when things go wrong, then only people they come, and then we reinvent that there is a need in terms of the uh, continual improvements and the culture of the entire organization. So your thoughts, because I've seen many times that things are going right, they are in the names of the business decisions. There are lots of rationalization and short-term gains, but in the long term, catastrophic failures happens. And how to change that trend, because we have all this data and information. So your wisdom related to that area. Thank you.
It's a good question, Gopi, and I think this is a really important point. And I think there's a differentiator here between what we necessarily have done in the Western world and what India is doing, or needs to do, or wants to do. I don't think some of the practices in the Western world are very good, to be honest. We very much have a view that, as Gopi says, it's going fine, so why do we need to worry? And what we call very short time concentration on a particular subject. So organizations will say, we need asset management. Please come and build an asset management program. Yes, we can do that. But it's a cultural change. It's how we live this, how we do it every day that is important. And so it's not just doing something once. You've got to have that commitment. And frankly, I think there's more potential for this to be got right in India than our short-term thinking in the West. But it's something we really need to work on. So whether it be asset management, operational risk management, process safety, my experience in the Australian and the US and the UK context has been we're very short-sighted. We think you do this once and it's done. We're talking about how we live the life of a whole asset. And so I think there's a great opportunity in India, and why I'm so passionate to support the Asset Management Society of India and Professor Pai, is that I think there's an opportunity to get this right and do it a different way. But it is cultural. It is changing how we think, how we look after these assets. And you've got the classic example in India, the Taj Mahal. There is an amazing asset that has been with us for a very long time and has been maintained. We have difficulty pointing to something like that in the Western world. So I think there's a great opportunity for India, but it's got to be different to how it's been done in the West, because we're failing, in my view.
Thank you, Glenn, for the excellent presentation. Even though at very short notice, you did it for us, and thank you for that, for supporting us all the way. And I welcome your thoughts, including during the conference ICMIM 2024 for India. I think there's a lot that the society can offer. We need to work together on this, and I'm sure that we'll be able to convince some of the people at the top that needs to be done. And I think our current Prime Minister is looking forward to Vikasit Bharat 2047. That's 100 years of Indian independence. So he wants to see a developed India. That's his target 2047. I think asset management will have a big role to play in that.
Mm.
Yeah, apart from that, just a small question on today's presentation.
Mm.
I think there's something called a butterfly effect.
Mm.
A butterfly flying somewhere in the Amazon
Mm.
can create a climate change, maybe in India or the rest of the world. So if we have these wind farms
Mm.
and they're going to change or affect the direction of the wind, and whether there are any studies done as to how they may affect
Yes.
the climate.
You've touched on a current point of a lot of research, and it's a very valid question because we're taking the energy out of the wind. We're affecting the wind, and if we do it in concentrated, localized areas, what does that do? Now, there's been a lot of studies and a lot of work done on the effect on bird life by wind turbines, and that was an early concern and remains one. But this broader issue that you're talking about is a research area at the moment that is getting a lot of attention. Now, it's very early days, but it is something that we do need to understand because the butterfly in the Amazon is a real effect. I mean, that's how we've got some human affected climate change, is because a change in one part of the world affects the whole world. So we do need to understand this. You're very correct. And we need to also understand it on that localized area. What does it do in that very specific area to things such as weather, a whole array of things. And it is a growing area of research and one I'm very interested to see what comes from it.
Okay, thank you.
Nothing, as we know, nothing in life comes at zero cost. There's a very old Western saying, there's nothing such as a free lunch.
Yeah. Right. Thank you.
Thank you.
So any other questions from anyone else?
Thank you.
Yeah. So if there are no other questions, then I think we'll call it a day. Thank you, Glenn, again. Thank you all for joining. It's 1 o'clock in India now, lunchtime, and I think it's about 6:30 p.m. in Australia.
Yep.
And Europe, maybe early morning. So thank you. Thank you all.
Right. Thank you very much. Take care.
Thank you.